All right, let's take a little journey into an invisible world, a world that's all around us, run by some real hidden heroes who work behind the scenes to make sure our digital lives, actually work. We are diving deep into the world of software testing. You know the feeling, right? We've all been there. You're just about to send a super important email, or maybe you're making that final move to win a game, and then, poof, it freezes, it glitches out, or it just disappears completely. That horrible, frustrating moment is exactly why the hidden world we're talking about is so incredibly important.
So how do we stop that kind of digital disaster from happening? Well, it's not magic. It's a really disciplined, methodical process. It's a whole field dedicated to hunting down those problems long before they ever get a chance to ruin your day.
What's really cool about this is how it shows the chain reaction. See, it all starts with a simple human error. A developer is under pressure, they make a tiny mistake. That little error then creates a defect, which is what we all call a bug, and it's just sitting there, hiding in the code. Then, when the software runs that specific bit of code, it causes a failure. That's the crash you actually see. The whole point of testing is to break that chain and to do it as early as possible. Okay, so here's something a lot of people mix up: testing and debugging. They sound similar, but they're totally different jobs. Think of it like this. Testing's goal is to find the defects. They're the detectives asking, where are things breaking? Debugging, on the other hand, is the developer's job. They take the detective's report, and their goal is to fix the defects. They ask, okay, why is this breaking? So one is about finding, the other is about fixing. A really crucial difference. To be really good at this, testers don't just, randomly click buttons and hope for the best. Nope. They live by a set of core principles, almost like a philosophy. These are the 7 golden rules that guide every single professional tester, our hidden heroes. Let's walk through them. First up, we've got principle number 1, and this one is maybe the most important and humbling rule of them all. Testing shows the presence of defects, not their absence. Think about that for a second. When a tester finds a bug, they've proven that a problem exists. But what if they run 1,000 tests and find 0 bugs? Does that mean the software is perfect? Absolutely not. It just means that none of those specific tests found a bug. Testing can find problems, but it can never, ever prove that there are no problems left. And that idea leads us straight into principle number 2. Exhaustive testing is impossible. Seriously. If you tried to test every single combination of things a user could do in even a pretty simple app, it could literally take centuries. It's just not possible. So what does that mean? It means testers have to be smart. They have to use their skills and special techniques to focus their energy where the bugs are most likely to be hiding. Principle 3 is a really big deal in modern software development. Early testing saves time and money. This one's huge. If you find a flaw in the plan for the software right at the beginning, it might take a few minutes to fix. But finding that exact same flaw after everything has been built and coded, that could take weeks and cost a fortune to untangle. It's simple, really. The earlier you find a problem, the cheaper it is to solve. Okay, principle 4 is fascinating because it shows us a pattern about where bugs tend to hang out. Defects cluster together. You've probably heard of the 80-20 rule, right? Well, it applies here. It turns out that about 80% of the bugs are often found in just 20% of the software's code. It's kind of like traffic in a big city. Most of the gridlock happens on just a few major roads. Smart testers know this, so they focus a lot of their attention on those complex, buggy areas. All right, next up, principle 5 is a warning against getting too comfortable. Tests wear out. This is a great one. If you keep running the exact same tests over and over again, eventually they just stop being effective. They stop finding new bugs. It's actually called the pesticide paradox. Just like bugs in a field can build up resistance to the same old pesticide, software can kind of get used to the same old tests. So testers have to constantly update and change their approach to keep finding new problems. Principle number 6 is all about being adaptable. Testing is context dependent. This just makes sense, right? You're not going to test a simple game on your phone with the same intensity as the software that controls a fighter jet. The risks are completely different, the goals are different, so the testing has to be different. The way you test something depends entirely on what that something is. And that brings us to the final principle, number 7. And this one is a heads up about a really dangerous trap: the absence of defects fallacy. So here's the question. What if you build a piece of software that is technically perfect, 0 bugs,
but it doesn't actually do what the users need it to do. Is it a good product? Of course not. A system that's bug-free but useless is still a total failure. It's not enough to just fix bugs. You have to make sure you're building the right thing in the first place. Okay, so now we know the rules they play by, but how do testers actually, do it? Let's peek inside their toolbox and look at the 3 main ways they systematically hunt for those tricky bugs.
So it really boils down to 3 main strategies. First, you've got black box testing. Here, you basically pretend you have no idea what's going on inside the software. You treat it like a sealed box. You just check that if you do X, you get Y, without ever looking at the code. It's just like test driving a car. You check the steering, the brakes, the radio, but you don't pop the hood. On the flip side, you have white box testing. This is the exact opposite. Now you're the mechanic with the hood wide open, looking right at the engine, at the code itself, to make sure every little part is working exactly as it should. And finally, there's experience-based testing. This is where the human element really shines. It's about using a tester's skill, their gut feeling, and their intuition to guess where the problems might be. Kind of like a veteran pilot who just knows when something doesn't feel right with the plane.
All right, so we get the rules and we get the techniques, but where does all this important work actually fit into the grand scheme of things? When does it all happen?
You see, in the old days, testing was often the very last thing that happened right before a product was shipped out. That's a terrible idea, and luckily, it's not how it works anymore. Modern testing starts right at the very beginning, during the planning phase, then it continues by reviewing designs in the code itself, then of course it happens when the software is being built, and it doesn't even stop at release. It keeps going with what's called regression testing to make sure new updates don't break old stuff. So it's not a single step, it's a continuous activity woven through the entire life cycle.
So let's end with this. The next time an app just works, you effortlessly book a trip, or you securely send some money, or you just enjoy a game without a single glitch, take a second. Think about all the invisible work that made that seamless experience possible. That's the work of the hidden heroes, the software testers, who hunt for failures so the rest of us can enjoy success.